Hey guys, this is our last rigid transformation that we're going to talk about in Unit 1, and that is rotations, which I'm sure we've heard of the word before. Just as human beings, we know a rotation means that you're going to spin something, turn something. So here's just a little example of when you might turn or spin something. We're going to figure out exactly how to do that on the coordinate plane, so you might want some graph paper for this as well. So a couple of quick things before we jump into some examples. So rotations, we got our title, another name, spin or turn. There's two directions for a rotation. And the directions we've heard of before, counterclockwise and clockwise. What we haven't heard of before is how we would describe these directions positively or negatively. So counterclockwise rotations going in this direction, we would describe those as positive rotations. So I have a little plus here for positive. Clockwise, going this way, the direction that a clock moves in, is also known as negative. So I have a little minus. We are going to only be doing rotations where the origin is the center of rotation. So 0, 0 will always be our center in this class for this unit. Okay, a couple other things that you want to jot down here. So we have 90-degree rotations means you're going to turn your paper one time. 180 degrees, turn twice. And you're probably starting to notice a pattern. 270 degrees, 3 times. And then 360 just kind of brings you back to where you started. So 360 degrees from here would be all the way around and then back to where we started. So back to start. We're not going to really do a lot of those because they're kind of silly. The image is the same as the pre-image. Alright, example 1 says rotate A 90 degrees counterclockwise. So just like we've done for all the other examples, we want to learn the notation so we don't have to keep writing out these long sentences. So our notation for a rotation, reflection and rotation both start with the letter R. So if you recall back from reflections, we used a lowercase r. So for rotations, we're going to use a capital R. So capital R stands for rotate. And then we're going to put a little subscript just like we did for everything else. And that's going to tell us how we want to rotate our figure. So 90 degrees counterclockwise, that would be a positive 90. So I'm going to put in 90 degrees. And then we want to tell, what is our pre-image. And then what is our image. Just like all the other transformations. So this is going to tell us the degrees to rotate and direction. Okay. So because we want to go counterclockwise, that's positive, so that means we are going to be rotating in this direction. Okay, so the easiest way to do these examples is to actually physically turn your paper. And 90 degrees just means one turn, so that means we're going to turn it in the counterclockwise direction one time. So that would be like this. So it's going to look as if our y-axis originally, now it looks like the x-axis, and our x-axis originally, now it looks like the y-axis. So then I'm going to record where this point is now, pretending this is my x and that this is my y. So this would bring me to the coordinates 1, 2, 3, 4, 5, 6 to the left. So -6, I would record that anywhere just so that I don't forget. So -6, 1, 2, 3, 4 up, so +4. Now I need to flip my paper back to the way it was facing, but it's okay because I've recorded my answer over here for A prime. Flip back to the way I was facing, and now I can record my pre-image. Coordinates were at 4, 6, and my image was, I recorded my answer over here where it should be -6, 4. And so now I can use this information to draw my rotation. So I'm going to count 1, 2, 3, 4, 5, 6 to the left and up 4. So here is my rotation. If these little arrows help you, feel free to draw them in. If they are confusing to you, this is not necessary. Like the vector was special for translations. This is just an extra little thing that might be helpful. Okay, here's another example that I want to go through. So example 2 says, rotate point A -90 degrees. So we have to remember, is that clockwise or if that's counterclockwise? And then we have our point right here. I recorded the coordinates for you, so you didn't have to figure them out. So first we need to decide, are we going clockwise or are we going counterclockwise? And because the notation has a negative here, we know this would be in the clockwise direction. So the opposite of the last example. That's going to be going this way. So you can probably start to notice a pattern like the last one. A rotated over to this quadrant. Now we're going in the clockwise direction, so A is going to probably land somewhere down here in this quadrant. Whoops. All right. So I want to turn my paper one time. So turn one time in the clockwise direction. So it's going to look like this. Turning once. Here we go. And before you turn your paper back, we want to record the coordinates of this, pretending that this is my x and this is my y-axis, right? So if this was my x-axis, 1, 2, 3, 4, 5, 6. This is A prime, 6, 1, 2, 3, 4 down, so -4. And it doesn't really matter where you put this point, because when you bring your paper back to the original facing, the way it was facing, you can record your final answer there. Here we go. So again, just kind of turn. We had +6, -4 for the coordinates of our image. So we just want to graph that and see if it checks out. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So A prime would be right here. And that would be 90-degree rotation clockwise. Oh, 6, -4. Example 3 is 180-degree rotation, and this time instead of a point, I gave you a segment. So we're going to rotate this segment 180 degrees. I wrote down the coordinates for you. Now notice that the 180 degrees is positive, which means we're going counterclockwise. So that would be this direction. So here. So if turning the paper is getting a little bit confusing for you, you can think of it this way. If I took this segment and I rotated it one time over to here, and then another rotation using increments of 90, right? So 90 and 180, my image is going to be somewhere over here. So if that's a little easier for you to visualize that way, that's another way you can think of it. Okay, so now I'm going to turn my paper. So again, I always want my x and y axis to be like this. So if you're still getting confused, like this would not be one turn because my x and y axis are not lined up, you know, vertical and horizontal. So one turn would be like this until my axes are vertical and horizontal. That would be one turn. And then a second turn would be, keep on going, until we have vertical and horizontal axes. Okay, so now I can see where my final image would be, and I'm just going to record my points over to here. So we have 7, -3 for A prime, and for B prime, 2, -8. And again, it's okay that it's upside down. You're going to turn your paper back around and record your final answers when we get there. Okay, so back to how we were facing. I know it's upside down, but still got the answer here. A prime would be at 7, -3, so then I can plot that. And B prime, we said 2, -8. And there's our image. So some of you might be looking at this and thinking like, oh, it kind of looks like the translations that we did because it looks like it's moving over to here, but it is not, because if it was, A would match up with A prime, but it doesn't. So that's how we would distinguish that this is a rotation versus a translation. And same thing with the reflection, like the B would have to match up with the B prime, but it's not. Properties preserved under rotations. I was just kind of talking about how, you know, A didn't match up with A prime, B didn't match up with B prime in terms of a translation. So when we look at a rotation, angle measure, betweenness, collinearity, distance, those 4 properties still are preserved, but also orientation now, because when I spin something, all of the order of the letters are still in the same order. Whereas with the reflection, you know, they flip-flopped, and same thing goes for the translation. So these 5 properties are both for rotations and translations. Here's an easy way to remember this little mnemonic, A, B, C, D, O. And that might help you recall some of the information when you're taking a quiz. Here's the last example, and I'm going to leave you guys to see how far you can get with this problem. I want you to write it down into your notebook. I want you to write the diagram. If you don't have graph paper, do the best that you can to sketch it, and then record the coordinates over here for the pre-image. And then do the best that you can with the rotation. See what you come up with. We'll compare answers when you come back to class. And I hope that you have a nice day.